Okay, let's continue with our test review packet. We finished page 3, so let's look at page 4. Okay, any questions with page 3? Yes. Oh, for the points of intersection. Yeah, so. Okay, so I entered these, would enter these functions and. So you want to make sure that you're in radian mode. And then 1/4. So I can do alpha y equals to get that n over d, 1/4 plus sine of pi x. And then my second function is 4 to the negative x, 4 to the negative x. And I'll do zoom 6 just so I can get a standard window. Really small here. I'm just going to zoom box around that region in the first quadrant. Okay, so I need to find 2 intersections. I'll start with the one on the left. So we'll do second trace intersect. I'm going to pick a point close to the intersection. So first curve, I'm going to just hit enter. Second curve, hit enter again. And then you're going to hit enter a third time. It says yes, question mark, hit enter. And then it'll find that first intersecting point for you. In this case, 0.178. And then we can do second trace again, intersect. This time I'm going to scroll to a point that is closer to my other intersection. Hit enter, enter, hit enter 3 times, and it should get you that intersection of 1. Right, to help. Okay. Any other questions with page 3? All right, so let's move into page 4. Okay, let's try this on our own, and I'll work through it at the same time that you guys do it. Okay. To report. Oh, sorry. Page 4, my bad. Guys, sometimes the X or the Y axis, sometimes one of the axes or both of them, sometimes neither of them is part of the shaded region. Sometimes the X or Y axis is just in the background to help give you some reference points. So I feel like some students feel like, oh, they got to involve the axis somehow, and they start making a really complicated boundaries involving all the lines drawn. So in this case, which line can we just ignore because it's really not part of the problem? Yeah, the y-axis, right? The y-axis has no part in this problem. It's just in the diagram to help you give an idea where the graph is. But we are going to need the x-axis because they do indicate that. So we're basically are only paying attention to whatever is identified in the problem. If it's not identified in the problem, then it's not a boundary. We can just ignore it. Okay, so we should have come to the conclusion that um, we have a vertical axis of revolution, we have a horizontal radius, we have this method, only one radius is needed, and I use this equation that is given to us. No, it's not in the proper form, right? If it's anything is horizontal, we know that we got to do some work with the original equation. The original equation is good for top minus bottom, but it's not in the proper form for anything horizontal. If you see a horizontal rectangle, horizontal radius, horizontal base length for cross section, you have to spend the time to rewrite your equation. Solve for different variables, solve for x. Oops, sorry, x equals 1. X equals -1, sorry. Wrong axis. Right minus left, right endpoint is sitting on the curve, which we rewrote in this form, 4 minus e to the y. Minus the left endpoint is sitting at the -1, so minus -1, so that will become a +1 there. If my expression is in terms of y, our bounds is also in terms of y. I'll find the lowest or the highest y value. Lowest is 0, the highest y value, which is going to be the intersection. Well, basically, wherever the natural log graph hits is at -1, right? We know this natural log graph has an x value of -1, so we can just plug -1 into the function to get the y value. We just want to find the y value of this curve, so I know what the x value is. So if I insert -1 in for x, natural log of 4 plus 1 is 5. So if I know the x value of a graph, I can always just plug in and find the y value at that point. So my bounds will go from where to where? From what's the lowest y value? 0. Highest y value is natural log of 5, or we can get a decimal version of that, which I put 1.61. Either is fine. Okay, try part B. Pretty good with number 2, part A. Same shaded region. Okay, same orientation. So equations will stay in the same form. Our bounds is the same. Remember, the axis does not play a role with your bounds at all. Your bounds is just for your shaded region. So it'll be the same as this method above. Okay, lowest to highest y value. Okay, try part C. Okay. As you're done with part C, I will go over part C, but if you're good with it, we're going to move on to page 7 and page 8. So if you want to get started with that, you can, or wait for me to go over part C. And so we're going to skip 5 and 6. We'll go to page 8. Page 7 and 8, sorry, page 7 and 8.
We get the calculator on the place.
Yes. Okay, well, pay attention to the way that this is describing the direction of our base length. X-axis, so x-axis is horizontal, parallel to it, so still horizontal. We haven't changed direction, so. So for part C, looks like the height is just a number. Sometimes they would describe the height in terms of the base. In this case, the height is just a number, so we can just put that number in for our formula. Any questions with page 4? Everybody okay?
Is there a non-calculator section of the quiz?
No, the whole thing's calculated. Remember with area, we don't square anything. Whatever we do for top minus bottom, that's all we need, right? We would square it if it was cross section or if it was rotation or anything that's volume, but
Is that a 6?
6, yeah, 5 equals 6. This is I mean, you'll get to use your calculator on your test. I want to show you though what a non-calculator FRQ question looks like. That means we'll have to do it by hand. We have to go through a power rule and work it out and produce an answer that way.
Someone already asked this, but there won't be one like this for it's non.
It'll be non-calculator, but you will get to use your calculator.
Okay.
It's not calculator question, but you get to use your calculator.
You recommend us trying it without the calculator?
Right. You can do it with a calculator. Okay, our homework will be pages 7 and 8. And so we're just working through and trying to get through as much as we can.
Or you should say units squared.
Oh, yeah. But just for reference, that if a problem on the AP exam, if they don't specify the units, then they won't take off points if you don't provide the units. Or they can't take the points off if they don't ask for it. Part B is only asking you for evaluation, so just have to set it up, and that's all we need to do. Part C, pay attention to those words. Parallel. Perpendicular to the y-axis. So y-axis is vertical. So if I want something that's perpendicular to it, it's going to turn that vertical to a horizontal. So anytime we see horizontal anything, we have to take the time to rewrite the equations. The equations, that 2 root x is not in the proper form for where we need it to be. So solve for x. The height is 3 times the length of the base. You have our area, just insert that area exactly as you see it with the integral notation to accumulate those rectangles. And then we also change our bounds, right? Our bounds are not going to be stacking these rectangles from bottom to top. Lowest y value is 0, highest y value is 6. And it's just asking you for the setup. Okay. Spend about 5 minutes, see if we can make progress on page 8. Okay, everybody okay with page 7? Sometimes students feel like, oh, they got to involve the x-axis, they got to split everything up. But in this case, if something is not mentioned in your boundary of shaded region, then it's just there for reference. So the x-axis is not going to play a role. It's just there to show where the graph is. But the only bounds we care about is the curve, the vertical line, and this linear graph. I see some students, they would try to split the problem up. They would start dividing things up between the above and below the x-axis. So we don't care about that. It's not a boundary. Thank you. Okay, part B, rotating about a horizontal line. The graph may be touching, but there's not a flat surface that it's up against, so it's going to be washer method. And vertical radius, so no need to rewrite our equation. The equation that's given to us is ready for us to use. So I think most of us will be to finish these 2 pages now. So tomorrow I'll be checking page 7 and 8. So tomorrow, hopefully we feel a bit more comfortable with area, this method, washer method, cross section. So tomorrow I want to start our AP review. There's one particular FRQ problem that we haven't seen before, so I want to spend tomorrow going over that. And then we'll take a little bit of a break from area volume tomorrow. And then next week is a short week. I'm not gonna see you guys Monday, Tuesday, or Wednesday. So Thursday, we'll do a full review of our quiz. And then Friday morning, I'll have a help session going over the morning review. And then next Friday will be your quiz. Okay. All right, then get your phones.
The exponent of the exponent.
That's right. There's a e to the x squared. Yeah. Okay, great. Thank you. I did. Thanks. Thank you.
So I've actually